Now, various forms of heat energy and the law of conservation of energy. So, there are different forms of energy like heat energy, chemical energy, electrical energy, nuclear energy. Okay. Now, see, we already discussed about the frictional force. Frictional force is non-conservative force. So, in the presence of non-conservative force, we know this thing, some part of kinetic energy that is lost and that will be transformed in heat energy, right? So here the transformation of that mechanical energy takes place into heat energy. Okay, heat is also one type of energy, right? So that is the heat energy. In winter we can experience this thing. Suppose to feel warm, we rub our hand, then our palm will be warm. So here, when we rub it, so we do mechanical work, means this mechanical energy that is transformed into heat. Then another form of energy that is chemical energy. Okay. So chemical reaction when takes place, so actually chemical reaction that is nothing but the rearrangement of atoms. So during this particular process, the energy is released as well as absorbed. Okay. So see, in some chemical reactions, heat is produced or heat is released. So these type of chemical reactions are called exothermic reactions. And in some chemical reactions, heat is absorbed, are known as endothermic reactions. So here, actually, when chemical reaction takes place at that time, there are different bondings between the molecules. Or in other words, we can say the molecules are bounded with each other with different energies. Okay. So when rearrangement of atoms takes place to form the new molecules at that time, this energy released or absorbed in the form of heat. So that is called chemical energy. Okay. Then after electrical energy. See, we know this thing, when electrical charges are in motion, then it constitutes the current. But now, to move electric charges, we have to provide some energy to it. Or if we provide some energy to it and it constitute the current, then their motions will be opposed by the conductor through which they are moving. And that opposition of the motion, that is represented by the resistance of that conductor. And due to that, the energy possessed by those charged particles or charges which are constituting the current, that will be liberated in the form of heat again here, right? So this particular energy associated with electrical charges, when they constitute the electric current, that is the electrical energy. Then nuclear energy. See, when the lighter nuclei fuse, means combines to form heavier nuclei, at that time, if we think about the total mass of those lighter nuclei which combines to form heavier nuclei, then total mass of lighter nuclei and the new formed heavier nuclei, so mass of that heavier one, so there is the difference in masses of these two. એ જે ચાર અહીંયા આપણે એક્ઝામ્પલ લીધું છે કે હાઇડ્રોજન ન્યુક્લિયાઈ લીધા, તો ચાર હાઇડ્રોજન ન્યુક્લિયાઈ હિલિયમ ન્યુક્લિયાઈ ફોર્મ કરવા માટે કમ્બાઈન થાય. So if we take the summation of the masses of these four hydrogen nuclei, then after if we measure the mass of helium nuclei, then mass of that helium nuclei that is less than mass of these four hydrogen nuclei. તો એ માસ ગયું ક્યાં વચ્ચેનું? That mass difference is called mass defect, and that converts into energy as per Einstein's relationship E equal to mc square or delta m into c square. તો આ ટાઈપનું જે રિએક્શન થાય એને ફ્યુઝન કહેવાય, ન્યુક્લિયર ફ્યુઝન પ્રોસેસ. પછી માનો કે યુરેનિયમ ટાઈપના હેવી ન્યુક્લિયાઈ હોય, રાઈટ? સો ઇફ heavy nuclei like uranium is divided into lighter nuclei, then also here the energy is released. એટલે યુરેનિયમનું જે ન્યુક્લિયાઈ છે એનું તમે માસ લો, પછી એનો બ્રેકઅપ થાય અને જે લાઇટર ન્યુક્લિયાઈનું ફોર્મેશન થાય એના ટોટલ માસનું કેલ્ક્યુલેશન કરો. તો અગેન હિયર the mass defect is there. Okay, and that particular mass converts into energy as per equation delta m into c square. તો આ જે ન્યુક્લિયર પ્રોસેસ થઈને એનર્જી રિલીઝ થાય છે એ ફિશન પ્રોસેસ કહેવાય. તો ફ્યુઝન થાય કે ફિશન થાય, બંને કેસમાં એનર્જી રિલીઝ થાય, and that is the nuclear energy. Clear to all of you? Now see, equivalence of mass and energy. So in early days, the scientists thought like this: the mass, that is the independent quantity that is always conserved for isolated system. But scientist Einstein represented this thing: mass and energy are related with each other. Mass and energy are equivalent. And as per equation E equal to mc square, mass and energy are equivalent. It implies that when mass m kilogram is converted into energy, then energy released, that is m into c square, where c, that is the speed of light, and that is 3 into 10 raised to 8 meter per second. Suppose we consider 1 kilogram mass which convert into energy, then energy released will be 1 into c square, so 3 into 10 raised to 8 whole square, so 9 into 10 raised to 16 joule. This much amount of energy will be released in this particular process, and this is tremendous large amount of energy. Clear to all of you? Example 6.10. Express A the energy required to break one bond in DNA having 10 raised to minus 20 joule energy in electron volt, then the kinetic energy of an air molecule 10 raised to minus 20 joule energy in electron volt, and the daily intake of a human adult 10 raised to 7 joule in kilocalories. Now see, energy required to break one bond of DNA, that is 10 raised to minus 20 joule. Now we want to convert it into electron volt. Now see, 1 electron volt, that is 1.6 into 10 raised to minus 19 joule. So we can use the unitary method like this: 1.6 into 10 raised to minus 19 joule, that is 1 electron volt. Therefore 10 raised to minus 20 joule, that is how much? So the energy, that is equal to 10 raised to minus 20 divided by 1.6 into 10 raised to minus 19. Solve this one, you will get answer in terms of electron volt. It implies that whenever you want to convert energy which one is given to you in terms of joule into electron volt, then simply you have to divide it by 1.6 into 10 raised to minus 19. And if energy is given to you in electron volt and you want to convert it in joule, then you have to multiply it by 1.6 into 10 raised to minus 19. Now question B, kinetic energy of air molecules, which one is 10 raised to minus 21 joule. Now if we want to convert it into electron volt, then again multiply it by 1.6 into 10 raised to minus 19, then solve it. We will get answer in electron volt. Then daily intake of human adult, that is 10 raised to 7 joule. Now we want to convert this one into kilocalorie. Now 1 calorie, that is 4.2 joule. So we can use unitary method like this. 4.2 joule equal to 1 calorie. Therefore 10 raised to 7 joule equal to how much? So now energy in terms of calorie. 10 raised to 7 upon 4.2. So that is resultantly 2.380 into 10 raised to 6. So we can write this is nearly equal to 2.4 into 10 raised to 6 calorie. So now joule is converted into calorie, but we want answer in terms of kilocalorie. Now 2.4, this 10 raised to 6 is divided in two parts, 10 raised to 3, 10 raised to 3. 10 raised to 3 means kilo. So your answer, that is 2.4 into 10 raised to 3 kilocalorie or 2400 kilocalorie. Clear? Now the principle of conservation of energy. So principle of conservation of energy says this thing: for any isolated system, the total energy that always remains constant.